Hey, everybody, welcome back to your Dawn of Autonomy podcast. I'm Dawn Zoldai, your host and the CEO of P3 Tech Consulting. We are continuing a great month that we've dedicated to this theme of ecosystem, sponsored by Grand Sky. And when you think about the ecosystem for the drone industry in particular, there's all kinds of pieces and parts that make operations happen. And one of them is cameras and sensors. And we have this great company with us here at UViRCO. We've got Riaan and Leon with us today. You guys rhyme. I didn't realize that until I just said that. And by the way, these gentlemen are here as guests of Volatus Aerospace, who has continued for now, I think, the third year in a row, the Volatus Above and Beyond series. So we were a little bit late today because these gentlemen are in the UK, but they're from South Africa. They were in travel status and they finally made it to, I think you guys are at IRED, and Tim Mamat was on our show a couple months ago as a Volatus guest. So it's like one big happy Volatus for your family here. Great to see you guys both. And thanks so much for joining us on the show.
Thanks.
All right, very good. Now, I remember meeting Riaan, I think it was.
Oh, both of us, actually.
Was it at Commercial UAV where I went up to your booth and I'm like, what do you guys do? And, and then we got to talking and I saw these sensors and cameras that you all put together and it was really intriguing. And so here we are. And so what I want to do, gentlemen, first I'd like you both to introduce yourselves. And then we're going to roll a quick video that shows a little bit about your facilities in South Africa. So Riaan, let's go with you first. Tell us a little bit about your background.
Riaan Rossouw of UViRCO Technologies. I'm the marketing and sales guy. Imaging is my world. And today, using Corona cameras to image problems on overhead power lines.
Awesome. Thank you. Now, Leon, the rhyming guy, tell us a little bit about yourself.
So I'm Leon Durant. I'm from South Africa. So I have a background in electronic engineering and currently at UViRCO, I'm the production manager.
Okay, very good. Well, thank you both. And a picture paints 1,000 words. So let's go ahead and roll this clip. right, excellent. A lot going on in that video. We got, I think, a little tour of your factory, and then we saw your equipment in action there.
Yep.
So bottom line, just to kind of upfront tell people, what is UViRCO all about?
UViRCO manufactures Corona cameras. Corona cameras are used to find locations of electric stress on the overhead power lines and substations. That is, in essence, the basics of what we do.
Okay, so tell me, what inspired you and your colleagues to create this company to focus on this very, very specific use case?
Well, the story actually starts way back in 1991 when a student at Eskom, for Eskom, the South African power utility, was wanting to do imaging of corona discharges. Back then they used film cameras. So you take a photograph, develop it the next morning at the 1 hour photo lab, find out you're out of focus, and then have to go do it again.
Oh boy.
Yeah, so you approach the CSR, that's the Council for Scientific and Industrial Research. It's a South African parastatal organization that does all kinds of research to the benefit of the country that might be too complex or expensive for private industry to do, and ask them to build them a camera that it can then visualize the corona discharge live. They took about a year and delivered the first unit, which he then used at Stellenbosch University. This unit is still in use there. The students have not managed to break it yet.
Really?
Yeah. Now, from there, they had a basic idea. It could only work at night because it was not solar blind. CSR scientists then took on the challenge to improve it and evolve it and make it better with each iteration. By the early 2000s, we started with solar blind cameras that could actually be used in daylight to do overhead line inspection. Most substations are not the safest place to be at night.
Yeah, I imagine.
Yeah.
I mean, frankly, it's not the safest place to be during the day, right? I mean, to do these inspections requires either a helicopter or somebody on a cherry picker or something like this?
Well, to date, most of it is hand-based cameras done from the ground, people literally walking the line.
Oh my gosh, so for miles and miles and miles.
Miles and miles and miles. One of our customers in Namibia, they bought a helicopter-based system, and he was very upset because now he spends every evening at home with his wife. Whereas in the past, he'd be out camping 5 nights of the week.
All right, so the traditional method was walking the line with a handheld camera that you'd have to basically take that film to, like you said, an hour photo the next day. It would be blurry, it wouldn't work. Initial iterations could only work at night, and then this improvement. So kind of walk us through that timeline then on milestones and developments in the company. And like, how did it pass from being like a publicly funded research project with the university to spinning off into UViRCO?
Well, the first unit, as I said, was developed in 1991, delivered in 1992. Some improvements over the years based on CSR research funding. And then about circa 2006, the South African government came to the CSR and said, guys, we give you millions of rands every year, but we don't see new businesses starting up. So the CSR stepped up and spun out the technologies that they developed for specialist applications to create commercial entities around them. UViRCO is the most successful by a huge margin of any one of the technologies that they spun out.
Well, that's amazing, the way the country basically decided to have this public-private partnership and then spin out a commercial company. We see some of that in the U.S. in terms of technology transfer, between the military and federal labs and industry and academia. But this is an amazing story and really a cool foundation and origin story here. So Riaan, tell us a little bit about then, you've got this first camera in the early 2000s. It's really, I think groundbreaking. I mean, would you agree?
Yep.
In terms of the technology that has been brought to bear here? And, you know, tell us what is so different about it, at least in that first model, compared to what other people were doing at the time. And then how you, over time, even improved it.
Well, the first model was essentially just a basic image intensifier that could see a little bit of ultraviolet. Most of the image intensifiers available are built for the military, for night vision devices. Okay. That unit improved with a bigger lens in the Coricam 3. Bigger lens collects more ultraviolet light, makes it more sensitive, allows you to use less of an image intensifier and still get good imagery. Then we went to the solar blind cameras, which was the Coricam 4, which was the first digital Corona camera as well, which would record video on an external recorder. Solar blinds, so you could use it in daytime, and it was the first camera that allowed you to false color the ultraviolet when you overlay it onto the visible image. Because inside the camera is actually two different cameras, the ultraviolet camera and a visible camera. Then from that Coricam 4, we went to the Coricam 504, which was a dramatically trimmed down, slimmed down, optimized electronic setup, more ergonomic. It featured a massive optical zoom, because finding the corona discharge blob is just the first step in the problem.
And when you say the corona discharge blob, just to be clear, on that video, we saw like, it looked like on a power line, red sparks.
Yeah.
Is that the blob you're referring to?
That's the ultraviolet signature that is overlaid onto the visible.
Okay, cool.
Okay.
And then how do you narrow it down further to appreciate what is actually going on there?
Well, now we're getting to that part. When you find that blob, that's fine. Now you know where the problem is. Yeah. Then you need to get a good optical picture, visual picture, to see what's going on there. Is there physical damage to the equipment? And if you're schooled well enough, how far along that physical damage has progressed? Okay. Now, there's been a whole variety of schemes to try and calculate a maintenance priority on that fault that you found.
Right.
The only methodology that works was actually created by US EPRI. That's the US Electrical Power Research Institute.
Okay. Oh, yeah. I've worked with them before.
Yeah. They published a daytime discharge inspector's guide, which then tells you if you find the discharge on X location, look for this type of visual damage. And they've created a table saying which priority A, B, C, or D to assign to the problem. Strangely enough, priority A is the lowest maintenance priority, priority D is the highest. Strange. Yeah, we turned that into a decision tree that followed a sequence of questions that the customer can then guide himself through and determine the maintenance priority.
Wow. All right. Really cool. And EPRI or EPRI is what Riaan's referring to. You know, basically an energy research group that puts out a lot of great products. So if you're in the space, absolutely check out what they have going on their website. Before we get into the camera, the actual like lenses and kind of deep diving into those, I want to make sure people understand, because they may not, what is the big deal about corona discharge? In other words, why are we even looking for it? What's the implication when you're seeing that blob, you know, with your camera? What does that mean? And
well,
yeah.
The corona discharge indicates a location of electrical stress. Okay. At that location, we literally have, due to the physics involved, electricity being thrown away into the air.
Oh, okay.
Right. Now, traditionally, people thought that is the big problem. However, when you calculate...
Now, why would that be? Is it wasted money? It's like, oh, that's dangerous because that can harm health? Or what's the problem with flinging off electric
throwing electricity into the air? In some countries that I've visited, the local utility tells me that about 20% of the power that they generate is just evaporated into the air.
So total waste.
Total waste. That's never delivered to the customer. It was never invoiced for. So that's power loss. When they start doing maintenance on their network and they can reduce that power loss, Western networks get down to a couple of percent. That is just normal structural. There's no ways of getting less than that.
Right.
Now, when you're doing the inspection and you find that fault, a single fault, the discharge, the value that's thrown into the air is peanuts, a couple of dollars a year.
Okay.
To go fix it, you have to send out a ground crew, send out a bucket truck, send out the equipment. That amounts to a couple of $1,000. It's just not worth going to fix it.
Okay.
Right? So the power loss is not a problem. However, when you're designing a pylon,
yeah,
and every instance that you're going to be using that pylon is going to waste, say, $50 a year, that quickly sums up.
Yeah.
Then it's worth designing a pylon that does not lose a lot of money.
Yeah.
Okay.
So how do these sensors help in terms of preventive maintenance?
Well, we're still getting to that part. That's the second part of the damage. There's 3 points of damage. One is the power loss.
Okay.
The second one is the actual physical damage happening at that location.
Okay.
When this corona discharge happens and we're throwing electrons into the air, it causes some very interesting chemistry to happen at that location. This chemistry then degrades the physical hardware. Now remember we said that the EPRI tells you to look for physical damage?
Right, right.
Right? Once that physical damage starts forming, if it progresses too far, then it causes an outage.
Oh, okay.
There's an outage, then the utility can't deliver the power, means they can't get money for it, and everybody loses.
Right.
Okay. The third problem is that electrical discharge into the air also creates audible noise and radio interference. Now, if it's in a rural area where the only thing that might be bothered is a couple of cows, nobody's going to bother with the noise. But if it's in a residential area, it can actually keep people from sleeping. Yeah, that's buzzing noise. The radio interference can also interfere with aircraft communications.
Like a giant bug zapper.
Yeah, the same kind of noise.
So not like a really loud, sleep noise machine, but something really horrible that's going to jack people up for a long time if it continues.
Yeah.
Yes.
Got it.
So yes, those are the 3 points of, what can I say, damage, bother from a corona discharge. Using the camera, you can then find these locations, assess whether it's going to be a problem that will cause an outage in the short term or cause damage that will cause an outage in the long term. And then you assign a maintenance priority, hand it off to the maintenance division, they go fix it.
All right. Well, a very worthy endeavor, to be sure, for not just the power companies, but like you said, the general public that's around these facilities that could be impacted by them, either from the noise or from an outage. I mean, it's not just the companies losing money. It's now businesses can't, conduct their business. Schools can't have classes. There's a whole bunch of cascading effects when the electricity goes out, to be sure.
Yeah.
So I want to show a picture here, and I want you to explain what we're seeing. If we could pop this one up. All right, here we go. We got two things that we're seeing right here. Tell us a little bit about what we're seeing in these images.
Now, this being the dawn of automation aimed at UAVs, this is our UAV-based camera. Okay, the UVS series. The left-hand one is the CarCam 8 UVS because it's got the thermal module with it.
Okay.
The right-hand one is the plain UVS, that is UV-Vis only.
All right, and walk us a little bit through this. I mean, looks like a relatively large drone. How much do these things weigh? And how easy are they to attached to the drone? Are they plug and play? Does it have to be a specific model? Like basically, how does it work?
Well, the model that is shown there was the DJI 300 or 350 series.
Yep.
That scale.
And that's a bigger one.
Yeah, it's the most often used for commercial entities.
It's a commercial used drone around the world.
Yeah. The camera fits into a Gremsy Pixie C gimbal. That's a custom version of the Pixie, right? And that just clips on via the little adapter plate to the DJI 350, 300 series. Can also be carried by a variety of other drones, too many brands to mention. The camera itself can also be clipped onto a Gremsy T3 gimbal, for instance, and used that way on many other larger commercial drones.
Okay, and you alluded to it, but you also have cameras that go on helicopters.
Yeah.
And you still have the handheld models as well, is that correct?
Yes, that's correct.
Okay, so let me ask you, just out of curiosity, at least in South Africa, how many people are using your cameras with drones versus the traditional way today? Like, have you seen a great progression to kind of move towards using drones instead of walking the line?
South Africa is very finance limited. Our national utility has only a few handheld cameras and 2 UAVs now?
2 UAVs, that's correct, yes.
Yeah. I mean, this is a minor compared to, say, a country like Saudi Arabia that has literally almost 100 handheld cameras and at least a dozen UAV units. Or in private consultancy.
Well, I made an assumption there based on what we're doing in the US. So in the United States, I mean, you may know this, a lot of our critical infrastructure, especially on the energy side, is privately owned. So in other words, it's not owned by the state or the federal government, whereas you're saying in South Africa and also in Saudi Arabia, that's a national endeavor.
Well, South Africa is a national endeavor.
Yes.
Saudi is Saudi Electric Company. Are they government owned? I'm not sure.
But South Africa is government owned.
Wow. Okay. Very, very interesting. That makes a lot of difference, I think, on who's funding it and, the extent of the programs that they're going to have. So clearly, you're doing some work in Saudi Arabia as well. Tell us a little bit about your global presence.
Oh, heck, we're everywhere, except the embargoed countries and Antarctica.
It's so funny that you say Antarctica, because I'm creating this digital media website called Autonomy Global, and I'm doing kind of global spotlights, and I did it by continent, but I didn't include Antarctica because I'm like, why would I? I mean, I'm sure there's stuff going on there, but and this just cracks me up because you guys are kind of in that place too. But so obviously working with Volatus and doing some things in Canada, did you want to elaborate on some of that work?
Yeah, no, we've been working a couple of years now with Volatus, getting some footage just to get back to some of the earlier footage. That was the first generation drone that we introduced. It was the CC8 UAV. So, weight-wise, it was around 2 kgs, so 2 kilograms, 2.7 kilograms with the attachment. And we've progressed now to the smaller drones that we just saw, the UVS series, which came in under a kilogram. So there's always a need to improve on technology, lighter sensors, it improves flight time. And with the EDRC and the commercial UAV expos that we had, Volatus, we partnered together and we've done a couple of series of inspections. They're currently busy with our sensor in the States, scanning some towers. And for getting marketing material, I think it's a very important aspect to educate everyone out there. What is this drone? What are they seeing flying around in the air? It might be close to their residential areas. It might be out in the open. But there's a big need to educate people on, the use of these applications so that they also understand where does it fit in everyday life.
Yeah, absolutely. You know, I feel so honored to be able to interview folks like you. I mean, I've already learned things. You know, I heard of corona discharge. I didn't really appreciate the three main, let's say, problems that it can cause, you know, not only for the companies, but for society writ large. I can tell you, gentlemen, you know, the general public, they don't appreciate that. They don't know it. You know, and energy companies, and I know you mentioned the Energy Drone Robotics Coalition. I love Sean Gare, and he was on the show back in May. You know, go to his event every year in Houston in June. You know, a lot of people, I think, believe the energy sector were really early adopters of this technology. I think there are those that tend to hold on to tradition. And, you know, like, what's this going to do? Can we have a drone flying close to a power line? How dangerous is that going to be? What about the, you know, the EMI, right? The electric magnetic interference between, you know, whether there's corona discharge or not, just a drone flying near a power line, and overcoming all of those concerns. And we're seeing now more and more usage in the energy sector, and you guys are clearly on the cutting edge of that. I guess my question to you is, in terms of, you know, your cameras and the quality of data, because we all know it's all about the data.
Yeah.
Right. The quality of data that they can produce. Are you seeing a widespread understanding of that across the energy sector, or is this something globally that you're still continually having to educate, not the public, but the actual energy clients on?
Yeah, the power utilities, with every one of our cameras that we sell, we also include training.
Yeah.
Ah, gotcha.
Right. Many of the power utilities, they have people who are old school, who have never used corona cameras, never even knew they existed, right? And we train them up how to use the camera, how to do inspections, how to do it right. We get to a lot of countries where the people are using corona cameras, but incorrectly, where they're living under certain illusions as to the output from the camera and misinterpreting it.
So let's dive deeper into that, because that's an important point. So
Yes.
you could have the best camera in the world, which let's just say is yours, and getting this unparalleled data, and then not understanding how to actually use it. How is that happening?
Well, back in the day, the corona camera's kind of first customer was a group who designed overhead power lines, and they wanted to figure out which corona, which setup produced the least corona. And they got into looking at the corona picture and saying, what can we quantify in the air to tell us the intensity of the discharge? Because we want to reduce that.
So is that like the size of the blob?
Yeah, the intensity of the blob. And they said, well, if they look at the blob, it's made up of a whole bunch of dots, the photons coming in.
Yeah.
And they started counting the dots, and they were already looking at very low intensities, right? And they could literally count the individual photons coming off.
Wow.
Right. Now we step into the future, and people are looking at the counts as an indication of severity. But the problem is the way the count in most of the cameras happen is not linear. It's spiked. It literally goes up to a point, the blobs start touching, your count drops.
Oh, so you could be looking at it at a given point in time, let's say at the bottom of that drop, if you will, and having an incorrect assumption about the level of discharge that's happening.
Yeah. But also the intensity of the discharge isn't all of it, because that depends on your observation distance.
Right.
Every time you double your distance, the amount of light reaching the camera quarters. That's physics.
Oh.
Depending on the weather at the time when you inspect, your intensity could be 0 because the discharge is extinguished by the ambient weather, or it can be maximal because the weather is good for getting a discharge. Well,
right.
Good relative to that. So basing any kind of assessment based on the count of the intensity of the discharge you're seeing is total folly. That is why the EPRI method does not even look at the count.
Ah, very interesting. Well, and like you said, there's a physical damage aspect to it that needs to be further explored, etc. So the bottom line is, it's not like a thermometer at the source. It's more like observing light over a distance. And the farther away you go, the less light is coming into that camera, and it can be very misleading.
That's correct.
So I guess maybe that's a great argument why drones theoretically are better than walking the line with a handheld, because a drone can get right up on that thing, right?
Yep.
Yes.
Okay.
The reason that drones are brilliant, okay, once you found that discharge, you need a good visual picture of that discharge location.
Yes.
To get a real understanding of what's going on there. With a handheld camera, you have to have a super zoom SLR to get a good picture, even from fairly low voltage distribution lines.
Yeah.
If you go into transmission lines, the distances get so large that even a 20 megapixel, 300 millimeter zoom camera can't deliver enough detail to see what's really causing the problem, or if there's damage. Whereas with the UAV, a regular camera, you can just lift it, fly within a half a meter, and see very, very small details.
Yeah.
Well, and not only that, but like consistently, right? So, you know, you use the word automation. Let's talk about an autonomous drone that can be programmed to fly the same path consistently, not just once, but over time, over a period of days or weeks or months. And then to have that like consistent path, to be able to see that change over time, I think is also really critical. You know, we have a couple other pictures of your latest, the KuroCam 8 HD UAV camera. So let's, oh, here we go. I love this picture. So you got two lenses here. What are we looking at?
Okay, the top lens is your ultraviolet and visible. The bottom lens is the thermal.
Okay.
That was actually our first UAV camera. It is a stripped down version of the handheld camera, because we had a number of customers saying they would like to do their thermal and ultraviolet inspection at the same time to spend less time doing the inspection.
Well, that makes sense. I mean, if you can, if you will, kill two birds with one stone, why not?
Yeah. And we listened to this and said, well, let's get the best thermal module we can get from FLIR. And we put that with our best visual cameras and our best ultrasonic sensor. Actually, not our best ultrasonic sensor, because all our cameras use exactly the same one.
Okay.
Right. And just put it into one small package for the handheld camera with an added grip that you could use it, and an LCD screen. For the UAV version, we took off the grip, took off the LCD screen, and everything else that we could do to lighten the weight, right?
Yep.
And mount that on a UAV. Now, the advantage that this unit has over the UVS, yes, it's heavier, but you can also dismount it and use it from hand. Because many utilities are fine with you flying up and down the power line, they are not quite ready for you to fly over the substations.
Oh, interesting.
Yes, and you have to inspect both the substations and the power line.
Okay.
So when you get to the substation, you can dismount the camera, use it as a man portable. Well,
that's handy. You know, and as you said, plugs and plays with a number of gimbals as well. So let's go ahead and pop up. There we go. Tell us what we're looking at here. This looks like, I mean, somewhat of an easy setup.
Yeah, it's fairly easy to mount.
Yeah, so that is the UVS. So that's the UVS series camera. So that's the ultraviolet and visible. It's mounted on a Gremsy S1 version 3 gimbal. So previously we had the Gremsy Pixie series, the C, the specially made gimbal, and now we also have it on a S1 version 3 gimbal from Gremsy as well, just to show that it is interfaceable with a number of different gimbals, not just one specific gimbal.
All right, that's excellent. So you said it's relatively easy to kind of plug and play or take this off and make this handheld. But you also said you do some training. So let's elaborate on that, because I think that's an important thing that potential customers and clients need to understand, that this isn't just here it is, figure it out for yourself. You said there are, there's data that they can misinterpret if they don't use it correctly. So tell us about your training program. Is that online? Is it in person? Like, what is that looking like?
Right. The training that we give with every camera is online. That's the only way we can do it cost effective.
Well, and globally.
Yeah, and globally. Otherwise, I'd be flying all over the world every day. Yeah. That training covers all the basics of the theory of corona discharge, the theory of how the cameras work, how you should be doing an inspection, what a typical report would look like. And that is based on years of experience gathering reports from customers all over the world and kind of finding the optimal stream through it all. That's even changing today from 5 years ago. It's changed dramatically how people report on corona discharges.
From counting dots to looking at other factors.
Yeah. And then, of course, the camera operation training as well. Now, we do offer in-person training, and we do offer on-site training with some of our distributors that organize get-togethers for multiple customers to come to one location, and we do training with a classroom of 40 people at a time.
Okay, very good. Now, it doesn't really go without saying, because we're talking about reports, we're talking about analytics, and yet you all make cameras, you do training on those cameras, but as we said, it's all about the data. So I assume there's a software package that comes with these cameras, and then how does the analytics happen on the back end in terms of those reports and other information that comes out to a customer in a usable fashion that they can make some informed decisions on their infrastructure?
Okay. On the software side, it's not like thermal, like you would from FLIR have software to do analysis.
Okay.
You actually just need a video viewer for the ultraviolet and visible.
Okay.
Just need a video viewer. VLC LAN works beautifully if you set it up that you can phase through the video and stop in individual frames, snap them, and use them in a Word report or Excel. However, today we're seeing many customers starting to do their reports in PowerPoint, because PowerPoint allows you to embed the video clip in it.
Now who are the people looking at these? Are these specific types of engineers or energy type experts? Like, who's the right person to look at these reports and say, this is what the problem is?
Typically, this would be the inspection managers, right? They would have somebody on staff who's normally trained up as an analyst.
Okay.
Okay. The maintenance people generally wouldn't look at it themselves. They just want the feedback. That insulator, that tower, this is the problem.
Fix it. Go fix it.
Yeah.
Okay. All right.
In many companies, the inspector is also the person who does his own analysis.
Okay.
That is why we train them all up. Some companies have gotten into a model where they use inspectors who do the inspection during the day, download the video footage in the evening, and the analyst comes in the next day, sits in the office and watches the videos and assesses what's going on.
Okay, excellent. So this is really an end-to-end service you're providing, essentially, even though your focus is on creating these amazing cameras. You're providing that training and that knowledge to help people understand how to use that data that they're getting. And these people are very focused in the energy sector on inspecting those towers and that critical infrastructure. So such a niche use case that you all have focused on. But as they say, and this is like niche, right? Niches make riches. And, you guys are clearly, you've carved one out here for this very specific use case. It's highly important to a lot of people.
Yeah. There is a second step to the software side. Sorry.
Okay.
Many utilities already have their own databases
Yes.
that they can drag the information into.
Right.
If the camera system is co-mounted with a thermal camera, so you got the UV-Vis and thermal,
Yep.
you can open the thermal files that we generate, the radiometric thermals, with our Coribase software, which is a simple image database software, or with ImageJ, which is a open sourced created by the US NIH software package for doing analysis.
Okay. Okay. Well, and we talked. I mean, I mentioned the idea of analysis over time, right? Looking at the same spot and where are the changes. And there's a lot of companies out there, and some of them, I'm sure, that are leveraging AI for that purpose to aid in if you've got millions of bytes, gigabytes, whatever, megabytes of data, to kind of quickly come through that and spot these things and say, okay, now you should be looking here. So, excellent, excellent. So, gentlemen, it's the end of 2024 almost, which is crazy to me. And we're on the horizon, and we hope of an amazing year in 2025. In the U.S., we're all praying for Part 108, Beyond Visual Line of Sight rule, which will help you in some of these inspections and the clients that you work with. I was just up in Canada. They're also pushing, BV loss as well and doing a lot of exemptions, etc. You're in the UK. Everybody's looking at this BV loss thing. But as you look ahead to next year, what are you the most excited about? And do you have any upcoming announcements on the horizon?
Well, one of the things when I joined the company and looked at this whole blob counting business,
the blob counting, I love it.
Yeah, and said there is value in the quantification if you do it right. There is potentially value there, but there's still a lot of research that needs to be done in how the intensity affects the materials.
Okay.
So next year we'll be launching a quantified UV camera. That will be the first step for researchers to calculate, to do the research and say X number of UV hours is causing Y amount of damage to the hardware, which will then allow maintenance engineers to get that and say, okay, this component can survive Z number of hours.
Right.
We've got X number of hours going out. If we predict into the future, we've got 5 years before we need to replace that part.
Well, and when you talked about that classification system, that kind of information is highly relevant to the priority, right? That you would place on a given asset.
Yeah.
Yeah. So that's going to be
discharge could be on a critical location.
Right.
But if your weather at that site and the intensity of the discharge on the given day when you're doing the inspection, and you can predict how long it's going to last, instead of doing a emergency outage and rushing equipment to site, you can say, wait a second, we've got up to 5 years to fix this at.
Right.
Let's schedule something down into the future and fix it then.
Well, and probably like airline flights, that when you have to do something on an emergency basis or do it tomorrow, it's going to cost you a little bit more than planning that out, and hopefully the cost of things come down, right? So, that's an amazing. When do you think you might be launching this?
Well, we're hoping to launch it Q2 next year.
Q2. Okay. Well, we'll keep our eye out. That is right around Exponential, which is going to be Houston, which is Petro Metro, and right before Energy Drone. So I'm sure. So where might we see you guys next year in person?
Well, we'll be in Houston as well. And then there's the commercial UAV leg has been taken to Europe as well. So in April in Amsterdam, the commercial UAV exhibition will also be there. So we'll be exhibiting at that expo as well. So we'll be in Houston and in Amsterdam.
Okay. So are you coming back to Vegas, or no? You're going to do the European one?
Do the European one next year, see how it goes. And I've got about 5 or 6 training sessions scheduled around the US.
Excellent, excellent. Well, let's stay in touch. If you've got demonstrations I've got Autonomy Global, we can post events, etc. So really excited for next year. Thank you so much for being on the show. I knew when I first met Riaan that you guys were doing really cool things. Once he started talking to me, I'm like, oh, you've got to get on my show. And then come to find out you're working with Vladis, and they're like, yeah, we'll put him on the show. We'll put him in our series. So really thankful again to Vladis for this Above and Beyond series, and for both of you taking the time to educate us about corona discharge and how your cameras are really making a difference in the energy sector. Thank you for what you do. And thank everybody out there for watching. We are out here.